In this video, we are going to go over two more theorems dealing with side lengths and angles. This is the long side large angle theorem. This is the name I created for this theorem because most books don't have a name for the actual theorem. So you can reference this as T35. It states that if two sides of a triangle are not congruent, then the longer side is opposite the larger angle. Let's take a look at a picture of this. This theorem says if we have a triangle A, B, C, and we can see that AC is not congruent to AB, and AC is also longer than AB. Well then, this angle B is going to be larger than this angle C, because this angle is opposite the longer side. Our next theorem, again I have named it large angle long side theorem. You can refer to it as T36. Since the name I made up is just to help me remember what the theorem says. So T36 says if two angles are not congruent, then the larger angle is opposite the longer side. Looking at this picture again, remember, this angle B was greater than angle C. So based on this theorem, since angle B is greater than angle C, then the side opposite angle B, side AC, is going to be longer than the side opposite angle C, AB. So the first theorem says that if two sides of an angle are not congruent, then the longer side is opposite the larger angle. And the second theorem says that if two angles are not congruent, then the larger angle is opposite the longer side. One theorem, the given information is the sides, and the other theorem, the given information is the angles. Let's prove T35. Here I have a triangle ABC, and I'm trying to prove that given two sides of this triangle, let's say side AB and side AC, since they're not congruent, then whatever side is longer, which we can see is AC, that means that this angle ABC will be greater than this angle ACB. So let me write down what we're trying to prove. So we're trying to prove that the measure of angle ACB is going to be less than the measure of angle ABC, and let's do a two-column proof. Let's start off by writing the given information. So we know the triangle ABC is given, and side AC is going to be greater than side AB. So they're not congruent, and this side AC is larger than the side AB. What we're going to do to help us prove this is create an isosceles triangle using some point X on the triangle. Here we have point X between A and C, and I have created X so that this length AB is congruent to the length AX. And remember also, since this is an isosceles triangle and those two lengths are equivalent, the angle ABX would also be congruent to the angle AXB. And that's by the definition of an isosceles triangle. I wrote down that I created a point X between A and C that made an isosceles triangle ABX. And because of that, since it's isosceles, the measure of angle ABX is congruent to the measure of angle AXB. And by the definition of congruent angles, we have that angle ABX is congruent to angle AXB. I can also say that the measure of angle ACB is less than the measure of angle AXB. Look at angle AXB as an exterior angle. We know by the exterior angles inequality theorem that an exterior angle is larger than either of the remote interior angles. And this angle ACB is a remote interior angle. Therefore, I can say that the measure of angle ACB is less than the measure of angle AXB. Since AXB is an exterior angle and ACB is the remote interior angle that corresponds to that exterior angle. And it's easy to see by the angle addition postulate that this angle ABX plus the angle CBX is going to equal the angle ABC. This angle plus this angle will equal the entire angle ABC. And from this, we can use the definition of inequality to say that ABX is going to be smaller than the measure of angle ABC. Before we move on, I noticed an error in my proof. So let's correct that together. The isosceles triangle theorem says that the angles opposite the congruent sides are also congruent. So I can't say, even though I know that those measurements are equal, I cannot say that they're equal yet. So I have to say that angle ABX is congruent to angle AXB, rather than what I had, the measure of angle ABX is equal to the measure of angle AXB. But that means in this next step, I will be able to say, based on the definition of congruent angles, that those measurements are equal. So the measure of angle ABX is equal to the measure of angle AXB. Luckily, it was an easy fix in our proof. I had just mixed up a couple symbols. So going back down to step 7, we can use substitution because looking at step 3, the measure of angle ABX is equal to the measure of angle AXB. So let's substitute AXB in for ABX. So the measure of angle AXB is going to be less than the measure of angle ABC. And that's by substitution. But look what we have now. We have that the measure of angle AXB is less than the measure of angle ABC. But we had up above that the measure of angle ACB was less than the measure of angle AXB. Here we have an AXB, and there we have an AXB. So ACB is less than the measure of angle ABC, and that would be by the transitive property of inequality. Since measure of angle ACB is less than the measure of angle AXB, and the measure of angle AXB is less than the measure of angle ABC, then the measure of angle ACB is less than the measure of angle ABC. And that's by the transitive property of inequality. And that is what we needed to prove. That given that one segment, in our case AC, was greater than another segment, AB, so they're not congruent and one is greater than the other, the angle opposite the longer side, angle ABC, is the larger angle. So, given side AC and side AB, where AC and AB aren't congruent, so we can say that AC is greater than AB, we proved that angle ACB, this angle, was smaller than angle ABC. So this angle opposite the longer side is larger. And that is theorem number 35.